In section 2.5, but before I get into that, I should review a little bit of section 2.4, especially as that video got insanely long and you might have not caught the stuff at the end of it. So I'm completely just making these up out of the top of my head so they're not in the handout or anything, but are all things that you should be able to do. So here's a first problem. I want to add those two fractions. That's an easy problem. And then we'll do something not quite as easy. And that's the second problem. And then we'll do something that's easy but maybe not so easy. This third problem was at the very end of the last section, and if you didn't make it through the hour plus in that video, maybe hour and a half, then you might have not seen me do something like that. So it would be great if you could pause the video, work these three problems, and just check yourself. But if you're not ready to do that, you could at least watch me do these. The top problem is the easiest of the three. I made them all adding because adding is easier than subtracting, but it's really not that much different. So the first problem, because the two fractions start off with the same denominator, I don't have to do anything but make the two numerators into one numerator. So I'm going to take the left numerator, 3x plus 2, and write it next to the right numerator in one fraction. And now I'm going to simplify that numerator by combining like terms. In the numerator, there's a 4x and an x. I can think of that as there's a 3x and an x, and I can think of that x as a 1x. And there's also a plus 2 and a plus 6. And when I combine those like terms, I get 4x for the x part of the numerator, 8 for the constant part of the numerator. The denominator is still x plus 2. I always have to check if my numerator will factor, and if it will factor, I should factor it, and that's the case here. The numerator, there's a common factor of a 4, and if I factor out a 4 from the numerator, I'm left with an x plus 2, and I strategically set the problem up like that because I wanted some canceling to happen, and the x plus 2 in the denominator is going to cancel with the x plus 2 from the factoring, and leave me with just a 4 in the numerator. The whole answer to this problem is just going to be the number 4. There's no x's at all. It's not x equal to 4. X is an unknown. It can take on any value in some sense. And when we did problems in this section, we checked by picking a random number, plugging it into my answer, and plugging it into the original problem for x. Because my answer doesn't have a letter, I could only pick a number and plug it into the original problem to check. And whatever number I pick for x, whether I pick 1, 2, 3, 4, 5, 6, 7, 8, or a million for x, when I plug that number in for x and simplify, it has to come out for 4 for my answer to be right. So I'm going to check this, and I'm going to check it by letting x equal to 2, because I don't like using 0 and 1, because sometimes I get true statements, and they shouldn't really be true, but the numbers are so, in some sense, trivial, that I get deceived. So I'm going to plug in for every x in the original problem the number 2, and I'm going to rely on my calculator to tell me what this simplifies to. And the only way that this answer is going to be right is if this comes out to be 4. Checking is optional, but it doesn't take that long to do. In some sense, it's mindless, so it's well worth your time. This way, if you made a mistake, it'll pop out at you. So there's the first fraction. Now I'm doing the second fraction. When I hit enter, if I see anything other than 4, I'll be worried that I made a mistake. If I see 4, I'm going to say my answer's fine. And because I see 4, I'm content with my answer. Second problem's a little bit harder. I have to factor both denominators. I didn't really give myself enough room to do this, but I'm going to force it in here. So the first denominator, it's going to factor, and the signs have to be minus and minus. and the numbers have to add up to -3. So my lasts are going to be -1 and -2, because -1 times -2 is +2, and -1 plus -2 is -3. So in my denominator, I'm going to put in -1 and a -2 for my first fraction. Second fraction's denominator has a square. It also needs to be factored, and that factors into x plus 1 and x minus 1, or x minus 1 and x plus 1. It doesn't matter the order that I write the denominators in. Unfortunately, those fractions can't be added because they don't have the same denominator, so I have to give each fraction what it's missing. The first fraction is missing the x plus 1 that the second fraction has. The second fraction is missing the x minus 2 that the first fraction has. I'm going to try to squeeze this up here. I'm going to multiply out the numerator of the first fraction and get 2x plus 2. And I'm going to try to squeeze in the three pieces of the denominator, an x minus 1, an x minus 2, and an x plus 1. Now I'm going to write the second numerator multiplied out. I'm going to multiply the 4 through the parentheses and get 4x minus 8. And I'm not going to have room here, but I'm going to write the denominator in the same order. I have the same components, an x minus 1, an x minus 2, and an x plus 1. I'm just kind of scribbling those in. After I have each fraction with the numerators multiplied out with the denominators equal, I can take the two fractions and make them to one fraction by writing the two numerator pieces, the 2x plus 2 and the 4x minus 8, in one fraction's numerator, and the pieces in my denominator I'll just write once. When you're adding or subtracting fractions, the denominators don't change. Now I'm going to simplify the numerator. I'm going to add the 2x in the 4x and get a 6x, and then do the 2 minus 8, 2 minus 8, and get a minus 6. So when I do that, I get 6x minus 6 for the numerator, and I still have those three pieces in the denominator. This was a lucky problem because it worked out so that my numerator factored just like in the problem above it, and anytime I'm simplifying or adding or subtracting fractions and a numerator factors, I should factor it, and that factoring can sometimes lead to canceling, and that's exactly what's happening here. That numerator, there's a common factor of a 6. When I factored out that 6, that left me with an x minus 1, and caused some canceling to happen because x minus 1s can cancel with each other. So my answer to the middle problem should be 6 over x minus 2 times x plus 1. I'm going to check it again. I'm going to save this problem for another sheet. I just don't have room to do it. I need to pick a number and plug it in for x. If I plug 1, 2, or -1 in for x, I'm going to get a 0 in a denominator. I'm going to get an undefined error. So I don't want to pick 1, 2, or -1 for my checking. For my checking, I'm going to go ahead and plug 3 in for x. I'm going to pull out another sheet of paper because this is getting really kind of jammed up. So I'm going to go for this problem and plug 3 in for x into the original problem. I'm going to go 2 over 3 squared minus 3 times 3 plus 2 plus 4 over 3 squared minus 1. I don't need the parentheses with the 3 squareds, but I could have it. So that's one thing I'm going to do, plug 3 into the original problem, and I'm also going to plug 3 into the answer that I think is the right answer. So I'm going to go 6 over 3 minus 2 times 3 plus 1, and hopefully I get the same results for each. So let me do the first one. I'm going to do it on screen here. So fraction 2 over 3 squared minus 3 times 3 plus 2 plus fraction 4 over 3 squared minus 1, and I get 3 over 2. It better happen that when I do this one, I get 3 over 2 again. So I'm going to go fraction 6 over 3 minus 2 times 3 plus 1 And if I see something other than 3/2, I'll be upset. Oh, good. So because when I picked the number 3 and plugged it into my answer in the original problem, I got the same number, I think my answer is correct. So last problem that I'm going to do to review section 2.4 is this problem down here, which is really the easiest of the problems that I made up. But if you didn't stick around and watch the end of the video, maybe it won't feel so easy. So the last problem, both pieces weren't fractions. And for me to add or subtract fractions, I like each piece to be a fraction. What I'm going to do is take the 3 and write it over 1 to make it into a fraction. And now I'm going to multiply this denominator, the 1, by x minus 3 to make it have an x minus 3. Basically, I'm going to make each fraction have the denominator x minus 3. The first denominator, if you multiply the 1 by x minus 3, you get x minus 3. So I'm making both fractions have the right denominator. If only one of the terms is a fraction, then probably the best thing to do is make the term that wasn't a fraction into a fraction and give it the denominator the other one has. So I'm going to multiply out this numerator, and I get 3x minus 9 over x minus 3. Second fraction is 2 over x minus 3. Now I can make the two fractions into one. Make this 3x minus 9 plus 2 over x minus 3. Combine these terms right there. Those numbers have opposite signs, so I'm going to subtract and get 3x minus 7 over x minus 3. This doesn't have a common factor, so it doesn't 1 parentheses factor. It doesn't have an exponent, it doesn't 2 parentheses factor. I think I can plug 2 in for my checking. So I'm going to check. I'm going to go 3 plus 2 over 2 minus 3, plugging in a 2 for that x in the original problem. And I'm going to go 3 times 2 minus 7 over 2 minus 3, plugging in a 2 for that x in my answer. And I'm going to see if they line up perfectly. So I should get the same result. So I'm going to go 3 plus fraction 2 over 2 minus 3, plugging 2 in for x into the original problem, I get 1. Oh. And if I do the same for the answer, do fraction 3 times 2 minus 7 over 2 minus 3 and hit enter, I also get 1. Beautiful. So I feel good that all 3 of my answers are correct. It's theoretically possible that you could have just been unfortunate, could have had a wrong answer and picked a number that made both your answer and the original problem correct, but that's pretty hard and really unfortunate, especially if you're not picking 0 and 1. So I feel good about those problems being right. Section 2.5 is similar to section 2.4, but it's different, and the different part is each of the problems has an equal sign. In section 2.4, I didn't get answers like x equal to some number because I was dealing with expressions and not equations. Expressions, you get answers, and your answers probably are just ugly fractions, similar to the answer that we just came up with this. So I didn't have x equal to any number for my answers, and the problems didn't have equal signs. When you're adding or subtracting fractions and you don't have equal signs, you get common denominators, and your answer doesn't have an x in it. So if I want to differentiate section 2.4 and 2.5, in 2.4, we're adding and subtracting expressions as opposed to equations. And my answer is usually a fraction, and it often has x's in both the numerator and denominator. In the last section, 2.4, I need a least common denominator, but the fractions never go away. If you look at every problem I did in section 2.1, how about never too strong of a word, the fractions rarely go away. Sometimes I can factor and cancel and have the fraction disappear on me, but that wasn't common. So the big difference between 2.4 and 2.5, 2.5, I see adding and subtracting, but there's an equal sign. So in 2.4, there wasn't an equal sign. My answer would use usually a fraction with an x in the numerator and an x in the denominator, but it wasn't x equal to some number. In 2.5, my answer will be x equal to some number, or maybe y equal to some number if the letter in the problem is y, or z equal to some number is possible as well. Z is the letter in the problem. But my answer is not normally going to be a fraction that has an x in the numerator and the denominator. Just like the last section, I'm going to need an LCD, but the fractions will go away on one of the first steps. Sorry for the scribble. So the big difference between 2.4 and 2.5 is the equal sign. And the equal sign will make the answers not be fractions that have x in the numerator and x in the denominator. My answer is going to be x equal to some number. Both 2.4 and 2.5, I need the LCD, but I do something different with the LCD in 2.5 than I do in 2.4. And in 2.4, the section that we did yesterday, or whenever you looked at that video, the fractions were generally in my answer. They never went away. In 2.5, my goal is to get rid of the fraction as soon as possible. This section, more than any in chapter 2, there's got to be a teacher at one of the high schools that teaches the problems differently than I teach them. And if I knew who it was, I'd speak with them about their strategy, because their strategy is bad in terms of it's way harder than what I do. And very, very often when I'm grading a test, I'll see this strategy, because there's other ways to solve the problems that don't clear the fractions, and that student will generally do really poorly. So if you think you know how to solve these already, you can work ahead and check yourself. It would be best to watch me do a few problems before you start working ahead, specifically because there are multiple methods to solve this problem, and the method that I use I think is far and away the easiest, but it's a little bit tricky for the first step or two. So for all the problems in section 2.5, at least the first 22, the first thing I'm going to do is factor all denominators when, if possible. It's not going to be the case in this problem, and it's not going to be the case in a lot of the early problems that my denominators are factorable. The denominators here are 3x, x, and 6. There's, it's not like an x squared minus 9 for my denominator, so there's nothing I could do here. Then I'm going to determine the least common denominator. And the big difference between what I did in the last section and what I'm going to do in this section is I'm going to multiply each term by the least common denominator. I'm going to do even a little bit more than that. I'm going to multiply each fraction, or each term really, by, I'm going to say, the least common denominator over 1. And what that's going to give me the luxury of doing is clearing the fractions. This would be legal to do if there wasn't an equal sign. But because there's an equal sign, it's legal to multiply not by numerator and the denominator. I'm not multiplying by something over itself. I'm multiplying by something over 1, which is a lot different than multiplying by something over itself. You can do that when you have an equal sign. You can't do that if there's no equal sign. Let me get this first chunk. There's nothing here. The least common denominator, I know the 3 and the 6 I can cancel with a 6, and an x and an x I can cancel with an x. In this problem, the least common denominator is 6x. And what I'm going to do is I'm going to take the pieces, 14 over 3x, I'm going to multiply it by 6x over 1, and I'm going to take the minus 5 over x, and I'm going to multiply it by 6x over 1, and I'm going to take the negative 1, 6, and multiply it by 6x over 1. This is a lot different than what I did in section 2.4. In section 2.4, I multiplied kind of each fraction by what it's missing, and I multiplied by the same piece in the numerator and the denominator. I didn't have something over 1. The reason I'm doing this problem differently is because it has an equal sign. If the problem didn't have an equal sign, this would create an imbalance. But since I could do something to each side of the equal sign, it keeps the equation true, it keeps the balance. So there's no factoring that needed to be done here. I determined the least common denominator. I multiplied each term by the LCD over 1. Now it's my big deal right here. Cancel fractions need to be canceled next. So I'm going to cancel the fractions. This one, I'm going to cancel the 3x with the 6x. The 14 and the 1 don't cancel, so that's not so interesting. The 3 and the 6 will cancel. 3 divided by 3 will be a 1. 6 divided by 3 will be a 2. The x and the x will cancel as well. So what I have left from this first fraction, the denominator of the fraction turns into a 1. The fraction that I multiplied by turns into 2 over 1. So I get 14 over 1 times 2 over 1. I don't need my calculator for that, but I can do my calculator. 14 over 1 times 2 over 1. My calculator will tell me that that's 28. By hand, I could do that. The denominator is going to be 1, so I don't really need to write a fraction. I multiply the 14 and 2 and get 28. I'm going to do the same thing for the next piece. I'm going to cancel. I'm going to cancel this x and that x, and that's legal to cancel because the 6 and the x are multiplied. If there was a plus sign between the 6 and the x, you couldn't. But when I cancel this, I get 1's in the denominator. I'm left with this minus sign. This first fraction turned into 5 over 1 when I canceled. The second fraction turned into 6 over 1 when I canceled. The minus sign's going to stay. The 5 times 6 is going to be a 30. It's really 30 over 1, but I don't need to write the over 1 because 30 over 1 is the same as 30. Bring down my equal sign and go to the right of the equal sign. I'm going to cancel this 6 with that 6. Again, if this was x plus 6, I couldn't cancel it, but because it is x times 6, I can cancel the 6's. What I'm left with is negative 1 over 1 because the 6 turns to a 1 when you cancel it. And then x over 1. I'm going to multiply the negative 1 times x and get negative 1x. The 1 times 1, I get a 1 in the denominator, so I don't need to write a fraction. So I canceled my fractions. And now I'm going to solve what's left. What I have now is a problem that has an x without an exponent that can be solved. It doesn't have fractions. I'm going to simplify this left-hand side. 28 minus 30 is negative 2. I don't need to factor because there's no exponent. I do need to divide by negative 1 because I don't want to know what negative 1x is. I want to know what positive x is. If I divide the left side by negative 1, the two negatives divide to be positive. If I divide the right side by negative 1, the two negative 1s cancel and become a positive x. So I claim that this is the answer. And the last thing I'm going to do is check. By checking, I go to the problem before I did anything, and I don't have a luxury of selecting a number. I'm told what number to check. In this case, I'm going to have to try x equal to 2 because that's what I think the answer is. So if I take 2, what I think my answer is, and plug it into the original problem, both sides have to reduce to the same number. Well, the right side's already negative 1, 6. For my answer to be correct, this left side has to also come out to negative 1, 6. So I'll give it a try. So for the left side, I'm going to get 14 over 3 times 2 minus and then 5 over 2. If I hit equals and see negative 1/6, then my answer's checked and I've done it correctly. And it does, so I'm good with problem 2. I'm going to move on to problem 4, and I'm going to use the same strategy. If a denominator can be factored, I'm going to factor it. Then I'm going to look at the denominators and determine the LCD. I'm going to multiply each term by the entire LCD over 1 to clear the fractions, and I'm going to solve what's left and check. So there's no factoring that needs to be done in any denominator. The only things in a denominator are 4 and an x. The entire LCD is just going to be the individual denominators. Multiplying by x will clear that. Multiplying by 4 will clear that. What I'm going to do now is multiply each piece by the LCD over 1. So I'm going to not multiply by 4x over 4x. I'm going to multiply by 4x over 1. It's kind of overkill doing that with the 2, but just so I'm being consistent, I'm multiplying every piece by 4x over 1. So I find out what the least common denominator is, what I would turn the denominators into if I was adding or subtracting the fractions. Multiply each by the least common denominator over 1. Now I go into canceling. First fraction, the x's cancel. The x's, when they cancel, they turn to 1s. So the first fraction turns into 7 over 1 times 4 over 1. And that's just going to be 28 over 1. I'm just going to write 28. The second piece, I don't really need to write the 4x as a fraction, because I could multiply negative 2 times 4x. 4x over 1 is just 4x. Because the second piece wasn't a fraction, it was kind of silly to write it as a fraction. I could multiply it easily, leaving it just as 4x. And negative 2 times 4x is negative 8x. Get to the right of the equal sign. To the right of the equal sign, the 4's cancel, and they turn into 1s. It leaves me with 1 over 1 times x over 1. And that's really just going to leave me with 1x, or x. I'm going to multiply the 1 and the x and get 1x. The denominators are 1. I don't need to write a fraction anymore. Fraction's gone. I need to solve for x. To solve for x, I'm going to add 8x to both sides. And this gives me 28 equals to 9x. I'm not doing any factoring because there's no x squareds. Now I divide by 9. This is going to be messy to check, but I can do it. I get 28 over 9 equals to x. I believe this is the answer. So I can't just randomly pick a number to plug in for x. I'm forced on what number to choose. So I'm going to sneak my checking in up here. I'm going to go 7 over 28 over 9 minus 2 and see if I can get 1/4. That turns out not to be that hard to enter on this calculator. I haven't entered a fraction over a fraction yet, but it's not going to be hard. So to check this on this calculator, I'm going to do the left side. When I do this on the left side, it better equal to 1/4. So I'm going to go fraction 7, go down to the denominator, and I'm going to hit the fraction key again. So my cursor is flashing in the denominator. I want to enter the fraction in the denominator, so I just hit the fraction button again. I'm going to go 28 over 9, and I arrow over and do my minus 2. So again, that looks a heck of a lot like that, at least close enough to that I believe it's okay. When if I hit equals and get 1/4, then I'm content with my answer. If I don't get 1/4, then I made a mistake. And since I got 1/4, my answer is correct. The bad thing about this section is at some point I can do perfect algebra and get a solution that doesn't check. And that's the thing that's really kind of a downer, but that's not going to come up yet. If I look at my denominators in number 6, I see an x and 2 x's. Multiplying by 2 x's or multiplying by x squared is going to clear the fractions because it's the larger of the exponents. So what I'm going to do is multiply each term by x squared over 1. I'm actually not going to multiply the 1 by x squared over 1 because it's not a fraction. I don't really need to kick in the over 1 part. So I figured out what I could multiply by to clear all the fractions. I multiplied every term by it over 1 except the thing that wasn't a fraction that it seems silly to do. The first piece, 1 times x squared, I can write 1x squared, or I can just write x squared. The second piece, this is really 2 over x times x over 1. And what cancels is an x. And what I'm left with is 2 over 1 times x over 1, because the x cancels and turns into 1. My denominators are 1, so I don't need to write a denominator anymore. And the numerators, when I multiply them together, I get a 2x. To the right of the equal sign, the x squareds cancel, and it leaves me with 8 over 1 times 1 over 1, because the x squareds cancel each other, they turn into 1s. And that's going to make the right-hand side turn into the number 8. This is the first one where I'm picking up a square. When I have a square, I need to solve by factoring. And I'm not going to solve by factoring until I get the problem set equal to 0. So I'm going to do a little work to get the problem set equal to 0, and then I'm going to factor. The first two problems I didn't need to factor because there wasn't an x squared, but this one I do. So I'm minusing 8 from both sides. That gets the problem set equal to 0. And now I'm going to factor, and this is easiest factoring. It factors into x plus 2 times x minus 4, because my signs had to be plus and minus. My last had to multiply to 8, subtract to 2. Now that I have it both set equal to 0 and factored, I split each factor up, set each one separately equal to 0. For the x plus 2 factor, I minus 2 from both sides and get x equal to negative 2. For the x minus 4 factor, I add 4 to both sides and get x equal to 4. So I think, as long as I haven't made a mistake, that I have two numbers that are going to work. My answer, or answers, are going to be x equal to negative 2 and x equal to positive 4. I need to check those, and I need to check those separately. And the checking's more involved because there's x's on each side. If I want to check the x equal to negative 2, I need to do this. I need to go 1 minus 2 over negative 2 and see if that equals to 8 over negative 2 squared. The negative 2 on the right-hand side absolutely is going to need to be in a parentheses. If I don't put it in a parentheses, my calculator won't do it right. So let me check the first one by doing both sides. So left side, I get 1 minus fraction 2 over the negative in the parentheses, and then 2. So the left-hand side reduces to 2. For this answer to be correct, the right-hand side also has to come out to be 2. I'm going to reduce this fraction now. I'm going to go 8 over parentheses negative 2 squared, and I get 2 as well. So I'm certain that the negative 2 works because when I plugged it in, I'm left with a true statement. Now I'm going to check the x equal to 4. By checking, I'll go to the original problem. I'll go 1 minus 2 over 4 and see if that equals to 8 over 4 squared. On the right-hand side, the 4 really doesn't need to be in a parentheses because it's not negative, but it would be okay. Let me do this now. So I'm going to go 1 minus fraction 2 over 4. Left-hand side comes out to be 1/2. For 4 to be an answer, the right-hand side needs to be 1/2 as well. The right-hand side is 8 over 4 squared. And on the right-hand side, I also get 1/2. So separately plugging the numbers into the x's in the original problem gives me true statements. So both those answers are correct answers. Still no factoring. The denominators are too simple to be factored. Multiplying by a 6 will clear the 2 and the 3. Multiplying by y will clear the y. I'm going to multiply everything by 6y over 1 because that will clear every fraction. So I'm going to go y over 2 times 6y over 1. The reason the 6 is because that's the least common multiple between 2 and 3. The y will take care of that y. So just like I did for the first two problems, I figured out what I could multiply by to clear the fractions, multiplied every term by that over 1, and now I'm going to go into canceling mode. I'm going to cancel this 2 with that 6. The 2 turns into a 1. The 6 turns into a 3. I'm left with y over 1 times 3y over 1. So I don't really need a fraction anymore. I need to multiply the y and the 3y. And when you multiply those, you get 3y squared. Second piece, y's and the y's cancel. They turn into 1s when I do the canceling. I'm left with 2 over 1 times 6 over 1. And I'm going to write 12 for that. And then to the right of the equal sign, 3 cancels with the 6. 3 turns into the 1. 6 turns into a 2. I'm left with 10 over 1 times 2y over 1, which is 20y, because I don't need to have the over 1 part because it's no longer a fraction. It's not necessary to write it as a fraction. Now, because there's a square, I need to set it equal to 0. I'm going to minus 20y from both sides. And really, unfortunately, I'm stuck with bottoms-up factoring. So to solve this, because I don't have the quadratic formula at my fingertips right now, I'm going to use bottoms-up factoring. I'm going to multiply, factor, divide, reduce, and bottoms up. So now I'm into the point where I need to solve this. So I'm going to multiply, factor, divide, reduce, and bottoms up to get the factoring done. The multiplying part is going to give me y squared minus 20y plus 36. My lasts are going to be tough. My signs have to be minus and minus. So when I go to factor this, I'm going to get 2 parentheses. The signs are going to be minus and minus. So I can do a minus 1 and a minus 36, a minus 2 and a minus 18, a minus 4 and a minus 9, or a minus 6 and a minus 6. I need to get a minus 20 out of this pairing, and this is the pair that gives me the minus 20. The other 3 possibilities won't help me out, so I'm going to do a minus 2 and a minus 18. So I've done the multiply, factor part. Now I'm going to divide, reduce, and bottoms up. I started off multiplying by 3. I'm going to divide by 3. Now I'm going to get my equal 0 back in. I could have written it here, but this technically is probably not appropriate to have it equal to 0 because it doesn't really equal the line above it because of that multiplying part, but now it will. First fraction doesn't reduce, bottoms up. Second fraction does reduce. So now I have my factoring done. I'm going to take each factor and set it equal to 0 now. I'm going to go 3y minus 2 equal to 0 and y minus 6 equal to 0. The 3y minus 2 is going to take me 2 steps to get the value of y, and it's going to be a fraction. So this is going to give me 3y equals to 2, and when I divide by 3, I get y equal to 2/3 for one of the answers that I hope checks. And then the y minus 6, I do plus 6 and get y equal to 6. So for this problem, assuming I haven't made a mistake, the answer or answers are going to be y equal to 2/3 and y equal to 6. It's really dangerous to not check, so I'm going to check. And that involves, a little bit of mess because of the fraction. So for the first checking, I'm going to check y equal to 2/3. Fraction's harder to check than not. I'm going to go to the original problem and go 2/3 over 2 plus 2 over 2/3 and see if I get 10/3. I only have to do the left side on my calculator because the right side's already just a single fraction. So messy but not impossible. So I go fraction over a fraction, so there's the 2/3 over 2. Double right arrow to get out of that fraction. Triple right arrow? I'm having a hard time getting out of this fraction. Really? Plus, I'm still in the fraction. Try it again. Fraction, 2 over 3 over 2, right arrow, plus fraction 2 over fraction 2/3. Looks kind of good. Like it look a little bit better, but I think I have that right. 2 over 3 over 2 plus 2 over 2/3. And when I hit enter, I get 10/3. That's a thing of beauty. So that's a right answer. That was a nuisance to check on my calculator, but way easier on my calculator than by hand. And now I'm also going to check the y equal to 6. And I'm going to do this. I'm going to go 6 over 2 plus 2 over 6 and see if that equals to 10/3 just by going to the original problem and changing each of the y's to 6. That's a lot easier. So I'm going to now go 6 over 2 plus 2 over 6, and if it gives me 10/3, I'm feeling good, and it does. So both the answers that I thought were correct were in fact correct, because when I plugged them into the original problem, I came out with a true statement. And that makes it so my answer is correct. So saying the answers are y equal to 2/3 and y equal to 6 is the perfect thing to say for that problem. 10, none of the denominators need factoring. I'm going to have to figure out what to multiply by to clear the fractions. Multiplying by 3 will clear the 3. Multiplying by x will clear each of the x's. I'm going to multiply by 3x over 1. So I'm going to go x over 3 times 3x over 1 minus x plus 1 over x. It doesn't matter which side I write the 3x over 1 on, and it's because of this minus sign. It might be easier if I write it on the left-hand side as opposed to the right-hand side. It kind of doesn't matter, but it might be easier to follow if I do it on that side. Generally, I always write the fraction to the right of that I'm multiplying by, to the right of the original fraction. But because that numerator had a binomial and there was a minus sign between it, I chose to write it on the left, and you might see why as I go through my work. So, ready to clear the fractions. First fraction, 3 cancels with the 3. They turned into 1s. Technically, I'm left with x over 1 times x over 1. The fraction goes away because I just have a couple of 1s. I multiply the x and the 1x, or the x and the x, and get x squared. Second piece, x cancels with an x. I have a minus 3 over 1 times x plus 1 over 1. And now the reason I did this like this is because this, what I really have now is minus 3 times x plus 1. And it's just not, it's minus 3 times the quantity x plus 1. It's not just minus 3 times x. It's minus 3 times x and minus 3 times 1. So when I'm clearing this piece, I have to think of the minus being attached to that 3. And I have to make this a minus 3x and a minus 3, as opposed to a minus 3x and a plus 3, or a minus 3x and a plus 1. So the reason, I knew that there's some subtleties going on here, and it was going to be easier to see the subtleties with the 3 written next to the minus sign. So I did it that way. But you get a minus 3x minus 3 to the right for that second fraction. And then here, I'm going to get 5 over 1 times 3 over 1, which is just going to be 15. So after I clear my fractions, I have a square, so I know I need to solve by factoring, which means I need to have the problem set equal to 0. Factoring doesn't help if the problem's not set equal to 0, so I'm going to minus 15 from both sides. When I minus 15 from the left side, the numbers have the same sign, so I add them and keep them negative and get a minus 18. Now I'm ready to factor. I know my signs are plus and minus, and I need to get that negative 3. I think a plus 3 and a minus 6 will do that perfectly, because 3 times 6 is 18, 3 minus 6 is negative 3, or 3 times negative 6 is negative 18 if I look at it that way. So I have it factored and set equal to 0. Then I'm going to split the factors up, set each one separately equal to 0. For the x plus 3, when I set it equal to 0, I minus 3 from both sides and get minus 3. For the x minus 6, I add 6 and get x equal to 6. So I think I have my answer. I think my answer is x equal to negative 3 and x equal to positive 6. I need to check both of these because for the problems in this section, it is possible to do perfect algebra and get an answer that doesn't check. So the first thing I'm going to check is the negative 3. So I'm going to go check x equal negative 3 by going negative 3 over 3 minus negative 3 plus 1 over negative 3, and see if that equals to 5 over negative 3. So work on the left side. Fraction negative 3 over 3 minus fraction negative 3 plus 1 over, didn't hit the fraction. Delete, delete, delete. Fraction, delete. Fraction negative 3 plus 1 over negative 3. And when I do that, I get negative 5/3. And that is the right-hand side. If I entered the right-hand side on my calculator, I'd go fraction 5 over negative 3. And it would also tell me that's negative 5/3, because that negative can be moved around. It can be brought in front of the fraction. It can be brought up to the numerator. But 5 over negative 3 is the same as negative 5/3. My answers are equal to each other, so that's negative 3 is an answer. Now I'm going to do the same thing for x equal to 6. I'm going to go 6 over 3 minus 6 plus 1 over 6, and see if that equals to 5 over 6. The 5 over 6 I won't even mess with. It's just a nice single number. And for this, I'm going to go 6 over 3 minus fraction 6 plus 1 over 6, and I get beautiful 5 over 6. So I came out with a true statement, so I feel good that my answers are correct. Still the same kind of problem. If I multiply by 2, I'll get rid of those 2's. If I multiply by x, I'll get rid of that x. I'm going to multiply everything by 2x over 1. And this first fraction, I'm probably going to multiply by the x on the left, the 2x over 1 on the left. So I'm going to multiply to clear the fractions. Multiplying by 2x is enough to clear the fractions. I'm going to multiply everything by 2x over 1. And for this middle fraction, because the minus sign and there's a binomial next to it, I'm going to multiply on the left as opposed to the right. You really don't have to do that, but it will be easier to not make a mistake if you do it that way. Multiply on the left as opposed to on the right. So did my 3 multiplications. Now I'm ready to cancel. First fraction, the x's cancel. Technically I'm left with x over 1 times x over 1. The x's will cancel, and x times x is x squared. Bring down this minus sign. Second one, the 2's cancel. I'm left with x over 1 times x plus 2 over 1. I don't need the over 1 part, but I'm going to leave the minus and the x. And when I drop the fraction, I'm going to emphasize that the entire x plus 2 needs to be multiplied by the x. And I'm going to multiply negative x times x and negative x times 2. So the 2 multiplications I have to do over here involve multiplying a negative x by both the x and the 2. And when I do that, negative x times x is negative x squared. Negative x times 2 is negative 2x. To the right of the equal sign, the x's cancel. When they cancel, they turn into 1s. I'm left with negative 2 over 1 times 2 over 1. And that's just a plain ordinary negative 4 if I haven't messed up. So now I'm going to simplify the left-hand side. Good things happen on the left-hand side because these x squareds cancel. I thought I was going to have to factor because the problem started off having an x squared, but the x squared worked itself out. When I simplify the left-hand side, the x squareds are gone. I don't need to solve by factoring. I do need to solve for x and not know what negative 2x is. To solve for x, I divide both sides by negative 2. And when I do that, I get what I think is my answer, x equal to 2. I'm worried that this is one that doesn't check, but maybe it does. So let me do my checking, and I just jam it up top here because I have the room and it's not so hard to do. So I'm going to go 2 over 2 minus 2 plus 2 over 2, and see if that equals to negative 2 over 2. That's a kind of insane amount of 2's. I could very likely mess up on my calculator entering this, but I'll try not to. So left-hand side, 2 over 2 minus fraction 2 plus 2 over 2. The left-hand side reduces to negative 1. The right-hand side, I can see it already, but I'll do it anyways. The right-hand side is negative 2 over 2, which is also negative 1. So because when I plugged the 2 in for each of the 3 x's in the original problem, because I was left with a true statement, I know my answer is correct, and so I can just say this is, put a little check sign next to it that I checked it, and I could write answer next to it to emphasize that it's the answer. So the nice thing about this chapter is if you're patient, almost every single problem that we do, there you have the luxury of being able to check your answer. So theoretically, given enough time, there isn't any reason to write down the wrong answer. 14 is the very first even problem in this section that has a denominator that's factorable. If I don't factor the denominator that's factorable, I might mess up. This 4x plus 16 has a common factor of a 4. And so I'm going to go ahead and factor that. And I'm going to rewrite that as 2 over 4 times x plus 4. So I know I'm going to need to multiply by x plus 4s to clear those x plus 4s. I also need to multiply by something that will cancel both a 4 and a 2. An 8 would do that, but that's overkill too big. If you just multiply by 4, that will be enough. I'm going to multiply by this whole denominator over 1, because multiplying by this whole denominator will cancel the x plus 4 and will also cancel that too. So for each of these, I'm going to just try to squeeze this in. I'm going to multiply by 4 times x plus 4 over 1. And hope like heck all the fractions go away. To the left of the equal sign, the x plus 4's cancel. Technically, I'm left with 3 over 1 times 4 over 1. I'm just going to write 12 for that. I'm going to bring down my equal signs. The next piece, everything cancels. Technically, I'm left with 2 over 1 times 1 over 1. The only thing that didn't cancel was this 2. And for that, I'm just going to write the number 2, because the denominator is 1 and 2 times 1 and the numerator is 2. Next piece is a little tougher. The 5 cancels, the 4 and the 2 cancels into a 1. And this leaves me with 5 over 1, this 4 turns into a 2, times 2 times x plus 4 over 1. That's a little bit harder to multiply. I can multiply the 5 and the 2 and get 10, and then multiply by the x plus 4. But I'm going to deal with this right fraction and make the right fraction 2x plus 8. And then when I multiply, I have to multiply the 5 by both the 2x and the 8. I won't need the over 1 part. It won't be a fraction anymore. So somehow that last term I need to get cleaned up the best I can. And the nice thing is if you make a mistake, it'll pop out when you're checking. So I believe that this, I haven't made any mistakes, but like I said, if I have made a mistake and I check, it's going to show up, because you won't get a correct answer if you made a mistake. So now I'm going to combine the 40 and the 2 on this side and get 12 equals to 10x plus 42. I'm going to minus 42 from both sides. On the left side, 12 minus 42 is minus 30. On the right side, the 42's cancel. I'm left with a 10x. Notice I'm not factoring because the problem doesn't have an x squared. Just have to divide to get the x solved for. I believe the answer, the only one answer, is x equal to negative 3, because on the left-hand side, the zeros lop off. I'm going to check, which could involve double checking because each side has an x. So for my checking, I'm going to go 3 over negative 3 plus 4 and see if that equals to 2 over 4 times negative 3 plus 16 plus 5 over 2. I have to do each side separately. I'll do the left side. 3 over negative 3 plus 4 gives me 3. So the left side reduces to 3. Now I'm going to work on the right side. The right side is 2 over 4 times negative 3 plus 16 plus 5 over 2 plus 5 over 2. And hopefully I see 3 when I get that done. Oh, beautiful. So again, because taking my answer that I think is the correct answer, changing each of the x's into the original problem to that number, simplifying each side separately because each side simplifies to the same number, my answer is correct. There's only one lonely denominator and it's x plus 3. That's what I'm going to multiply by. I'm going to multiply by x plus 3. I'm going to multiply by x plus 3 over 1 just because it'll make it be less likely to make mistakes. So I'm going to multiply this by x plus 3 over 1. The 1, I don't really need to multiply it by x plus 3 over 1 because it's not a fraction. I don't need the over 1 part. But I could. It's just I'm going to wind up getting rid of it anyways. But I kind of needed a parentheses. When you multiply by a number by a binomial, you should probably have a parentheses. So because the only denominator was x plus 3, multiplying each term by it's going to clear the fractions. First, canceling, I get 2x over 1 times 1 over 1. Don't need a fraction anymore because all I have is 1 in the denominator. This 2x and this 1 multiply to be 2x. To the right of the equal sign, 1 times anything is itself, so I'm just going to get an x plus 3. Next fractions, cancel, cancel. You're left with minus 6 over 1 times 1 over 1. I'm just going to write a minus 6. This is a nice problem because there isn't an x squared. I don't need to factor. It's a bad problem because my answer is not going to check. And this can happen. I don't think I've made it a single algebra error. And that can happen, that you do your algebra perfectly and you get an answer that doesn't check. So I'm heading towards that right now. I just combined those. 3 minus 6 is negative 3. And I'm going to minus x from both sides. I think, well, my algebra says that negative 3 should be a solution. I can tell that I've done perfect algebra and this number's not going to check. And that happens when you get an undefined in your checking or a math error. So if I try to check this, the thing that's going to happen that tells me that I didn't make a math error but the solution doesn't check is that I'm going to get a 0 in my denominator, which is an undefined. And when you get an undefined, that's not checking because you get like an error equal to 1 minus an error or something, and that's not true. So on the left-hand side, if I did this on my calculator, I did 2 times negative 3 over negative 3 plus 3. The left-hand side gives me a math error because it has a 0 in the denominator. This piece is undefined. In the right-hand side, this piece is 6 over 0. This is really undefined equals 1 minus undefined. My calculator can't show me that, but if I do the right-hand side of my calculator and do 1 over 1 minus fraction 6 over negative 3 plus 3, and I get a math error again. Negative 3 is not a solution because when I plug it in, I don't get a true statement. Undefined doesn't equal 1 minus undefined. In fact, anytime I generate a solution and I get an undefined anywhere when I'm checking, we call that solution extraneous, and it's not a checkable solution, so it's not a solution. When I go to write my answer to this problem, the only solution that my algebra produced doesn't check. I have options. I can say there's no solution to this problem. And that's completely right. The only potential solution was negative 3, but it didn't check. Or I can say the algebra produced a solution of -3, but it did not check, so there is no solution. So the big thing about problem 16 that makes it horrible is that I didn't make a math error, but the answer I came up with, when I tried to check it, I got undefined, and that's exactly what happens in a problem that you've done perfect algebra, didn't make a math error. That's what it looks like when you have a solution that the algebra produces that isn't a solution because it doesn't give you a true statement when you plug it in. I think there's a handful of those coming up, and I don't think I've ever put one of those on a test, so it's not a deal breaker. 18, there's a denominator that can be factored. This x squared minus 1, I'm going to factor it. I'm going to write this as 3 over x plus 1 equals 2x over x plus 1 times x minus 1. And I'm going to multiply to clear the fractions. Multiplying by x plus 1 would clear the x plus 1s, but not the x minus 1s. I'm going to multiply each piece by x plus 1 times x minus 1 over 1, because that will clear both the fractions. So I find something that's going to clear the fractions when I multiply it by, and I multiply each by that over 1 like I've done for every problem. Now I'm going to cancel. Cancel, cancel. I'm left with 3 over 1 times x minus 1 over 1. I really need the parentheses with that x minus 1 because the 3 needs to be multiplied by both the x and the 1. So when I clear that fraction, I get 3 times x minus 1 on the left side, which is just 3x minus 3. On the right side, I'm going to cancel the x plus 1s and the x minus 1s. So I have 2x over 1 times 1 over 1. Everything in the right piece went canceled away, so I just had a bunch of 1s left. The denominator canceled there, so I have a 1 left. So to the left of the equal sign, I just have a 2x. Lots of ways to solve this, but none of them require factoring. What I'm going to do is this. I'm going to minus 2x and add 3 to both sides. You can certainly minus 3x from both sides. If you minus 3x from both sides, you'll have to divide by a -1. My strategy of minusing 2x on the left side gives me a 1x, cancels the 3's, and on the right side cancels the 2x and gives me a 3. So I think the answer is x equal to 3, and I need to check that. So I'm going to come up here and check. I'm going to check to see, does 3 over 3 plus 1 equal to 2 times 3 over 3 squared minus 1? Probably will work, but I'm not certain. I haven't messed up. So left side, 3 over 3 plus 1. On the left side, I get 3/4. Better get 3/4 on the right side, otherwise I've messed up. And this is not the kind of mess up where you get an extraneous solution. The only time I can say the solution doesn't check and I haven't made an algebra error is when I get a 0 in the denominator. If the solution doesn't check and I don't get a 0 in the denominator, then I've made an algebra error. So if this right side doesn't come out to 3/4, then I did something wrong and I have to hunt it down. So the only time in this chapter where we're going to say the solution is wrong or doesn't work is when you get an undefined. And thank gosh. So both sides came out to 3/4, so I feel good about this solution. '20's a lot of factoring that needs to be done. Good. Only 2 more hard problems, and then we get to the easy problems in this section. I'm going to factor that denominator. The first 2 denominators don't factor because they don't have common factors and they don't have squares. The last denominator does factor. I know that my first have to be a couple of x's. I don't need bottoms up factoring because there's not a number in front of the squared. My signs have to be plus and minus, and I have to get a negative 2 out of there, so I get a plus 1 and a minus 3, I believe, because 1 minus 3 will give me a negative 2. I'm going to multiply by that entire denominator over 1. It'll clear all the fractions. So I'm going to go x plus 1 times x minus 3 over 1, x plus 1 times x minus 3 over 1, x plus 1 times x minus 3 over 1. Now I'm going to get into canceling mode. Cancel the x plus 1s. I'm left with x over 1 times x minus 3 over 1. Don't need the over 1 part, but I do need the parentheses for the x times x minus 3. The x times x minus 3 is going to give me x squared minus 3x. So I'm multiplying an x times an x and an x times a minus 3. Next piece, cancel the x minus 3s. I'm left with 2 over 1 times x plus 1 over 1. Don't need the over 1s. Do need the plus 2 times x plus 1 on that side. And when I do that, I'm going to get 2x plus 2. I'm going to multiply the 2 by the x and get 2x, the 2 by the 1, and get plus 2. Right side, both the x plus 1s and the x minus 3s cancel. Everything turns into 1s. Technically, I'm left with 2 over 1 times 1 over 1. Don't need the over 1s. I multiply the 2 and the 1 and get 2. There's a square sum to solve by factoring. This is the kind of problem that I sometimes sneak onto the test trying to be kind. It's the kind of problem where my kindness is usually not considered kind. Because this is easy factoring that if you're working ahead of me, you might miss. So I'm going to simplify the left-hand side. Minus 3x and plus 2x is a minus 1x. Don't need to write the minus 1, but I certainly can have the minus 1. Because there's an x squared, I'm going to set it equal to 0 and solve by factoring. The minus 2 from both sides, and I get x squared minus 1x equals to 0. That all of a sudden is not like anything we've factored in quite some time. It's just common factor factoring. When I go to factor this, I'm going to factor out an x, take an x away from each piece. The first piece had 2 x's, I'm left with 1x. The second piece had a 1 in x. When I factor out an x, I'm left with a 1. So now I have it factored and set equal to 0. Each factor that has an x is going to give a potential solution. The first one I get is 0 as a potential solution, and the x minus 1 factor gives me a 1 as a possible solution. I better check because I think something bad's going to happen here. So first thing I'm going to do is check the 0, because the 0 is a nice number to check. And for checking the 0, I need to go 0 over 0 plus 1 plus 2 over 0 minus 3 equals to 2 over 0 squared minus 2 times 0 minus 3. So that has to be a true statement. I have to do each side separately. So I'm working on the left side now. 0 over 0 plus 1 plus fraction 2 over 0 minus 3. Left-hand side reduces to negative 2/3. For my answer to be correct, the right side has to become negative 2/3, and it will. The right-hand side I do 2 over 0 squared minus 2 times 0 minus 3. The 0 really didn't need to be in a parentheses when I squared it, but it would have been okay to do it. And I got negative 2/3. So 0 is a solution to this problem. It would be wrong to say there's no solution to this problem because 0 works. Now I'm going to check the x equal to 1 that I got over here. Well, maybe that'll work as well. When I check the x equal to 1, I'm going to go, so check, I think it actually works. X equal to 1, I go 1 over 1 plus 1 plus 2 over 1 minus 3. See if that equals to 2 over 1 squared minus 2 times 1 minus 3. Do each side separately. Left side is 1 over 1 plus 1 plus 2 over 1 minus 3. Left side comes out to negative 1/2. The right side better be negative 1/2 as well. So now I do the right side. 2 over 1 squared doesn't need to be in a parentheses, but you could. Minus 2 times 1 minus 3. Beautiful. So both 0 and 1 are solutions. So this problem has two solutions, 0 and 1. If you didn't factor this properly and catch this common factor, you might have missed the solution of 0. And it's okay for 0 to be an answer. So the answer are x equals 0 and 1. I'm wearing out again, which means you must be wearing out too. Fortunately, there's only one hard problem left. That's this problem 22. And then the rest of the problems are cross-multiplying problems, and they're way easier. So I'm going to multiply by this denominator and that denominator over 1 to clear the fractions. Multiplying by x will clear that fraction, and multiplying by x plus 1 will clear that. And there's no fraction there, but I still have to multiply it. So I'm going to go 2x times x plus 1 over 1 minus 4 over x plus 1 times x plus 1 over 1. And the right-hand side, I don't need to show the fraction, so I'm just going to go 3x times x plus 1. I don't need the over 1 part because that side's not a fraction. Now I go into canceling mode, cancel, cancel. I have 2 over 1 times x plus 1 over 1, which is 2 times x plus 1. Don't need a fraction, do need the parentheses. Clear the parentheses and get 2x plus 2. Next piece, x plus 1's cancel. I'm left with minus 4 over 1 times x over 1. Don't need the over 1's, but I do need the minus sign, and I need the 4 and the x. To the right of the equal sign, nothing cancels, but I have to multiply 3x times x and get a 3x squared, 3x times 1 and get a plus 3x. So my fractions are gone. That's a good thing. The bad thing is I have a 3 in front of the x squared, which makes me feel like I'm going to have bottoms up factoring. On the left-hand side, I'm going to simplify by making the 2 minus 4x into a minus 2x. So the left-hand side, I can make minus 2x plus 2. Because there's a square, I need to get the problem set equal to 0. I like to have the x squared term positive, so I'm going to get everything on the right-hand side by adding 2x and minusing 2. When I add 2x and minus 2 on the left side, I get 0. On the right side, I get 3x squared plus 5x minus 2. It's bottoms up factoring. I'm going to deal with it. I'm going to multiply, factor, divide, reduce, and bottoms up. First thing for the left-hand side, multiply. I get x squared plus 5x minus 6. Factor that. My signs are plus and minus. My last have to subtract to be 5, which are going to be positive 6 and negative 1. So I multiplied, factored, now divide, reduce, and bottoms up. And when I do that, I get 6 over 3, which turns into a 2. 1 over 3 returns into the 3x minus 1. So now I have the problem set equal to 0, factored. I'm going to squeeze it in right over here and try to finish this up. For the x plus 2 set equal to 0, I minus 2 from both sides and get x equal to minus 2. For the 3x minus 1 equal to 0, I add 1 to both sides and get 3x equal to 1, then divide both sides by 3 and get x equal to 1/3. I believe the answers to this problem, if I haven't messed up, are x equal to negative 2 and x equal to 1/3. I'm going to check them both and pull out a new sheet of paper to check them. So I'm going to check the negative 2 first. I'm going to go 2 over negative 2 minus 4 over negative 2 plus 1. That best equal 3. If it doesn't equal 3 and I don't get undefined, then I messed up. So first check. Fraction 2 over negative 2 minus fraction 4 over negative 2 plus 1. And I get beautiful. So I know that negative 2 is the solution because when I plug it in, it checks. Now the 1/3, I'm going to go 2 over 1/3 minus 4 over 1/3 plus 1. And that has to equal 3. That's going to push my calculator limit to the max here. So first when I go fraction 2 over fraction 1/3 minus fraction 4 over fraction 1/3 plus 1. I can't believe I was able to actually do that. That looks a heck of a lot like that, as much like that as it needs to look like. And when I hit enter for that, beautiful, I get 3 equal to 3. And that's what I needed to have happen. So I'm left with a true statement. Because I'm left with a true statement, I know my answer of negative 2 and 1/3 are perfectly correct. So the first 22 problems, I'm going to do essentially exactly the same way. I look at the problem. If any denominator can be factored, I factor it. After I factor any denominators, I multiply each term by something over 1 and enough to clear the fractions. And then I solve what's left. And then I check my answers. In the next section, 23 through 30, these are the ultra-kind problems. What they have in common is they all are proportions. They're just one fraction equal to another. Each of the problems between 23 and 30, I could solve just like I did the problems 1 through 22, but I don't have to. I can solve all of these by cross-multiplying. So 23 through 30, they are completely set up to cross-multiply because what they have is a proportion, one fraction equal to another, and I'm going to take advantage of that. I'm going to cross-multiply this way, in that way, and get x times 28, or 28 times x, equals to 2 times 7. This gives me 28x equals to 14. Divide both sides by 28. Right-hand side reduces to 1/2. Left-hand side is x. I think that's my answer. I'm going to check. For my checking, I need to have 2 over 1/2 equal to 28 over 7. So let me do the left-hand side first. The left-hand side is fraction 2 over fraction 1/2. Left-hand side reduces to 4. I don't need my calculator for the right-hand side, but I have it, I'll use it. The right-hand side is 28 over 7, which is also 4. So because I have a true statement, I'm done. It took 2 steps. So beautiful. Same thing with 26. I'm going to cross multiply. I'm going to cross multiply down and up. The up, I'm going to have a 5 times x. The down, I'm going to have a 7 times 10. So I get 5x equals to 70. I'm going to divide both sides by 5. If you can't divide 70, divide it by 5. In your head, you can use your calculator to get it, which I believe is 14. But I can go 70 over 5 and get my answer of 14. Let me check this real quick. So for checking, I'm going to see if 7 over 5 equals to 14 over 10. I know that that works, but I can do the right-hand side just fine. 14 over 10 on the right-hand side. If I did that on this calculator, 14 over 10 gives me 7/5. So plugging in and reducing both sides, I get 7/5 equal to 7/5. So my answer is correct because I have a true statement. A little bit messier on 28. Cross multiply one direction. And it's better to write the 12 to the left of the x minus 2 when you do that. And cross multiplying the other way, it's probably better to write the 2 to the left of the 4x. Multiplication is commutative. You can put either thing on either side. This is probably the nicest way to set up 28. The cross multiplying up, I multiply 12 by x and by minus 2 and get 12x minus 24. The other direction, I get 8x. There's no factoring because there's not a square. Ultimately, I need to get the x's on one side. I'm going to need to divide. If I minus 12x from both sides, I get a lot of negatives, but I can live with some negatives right now. On the left-hand side, the 12x's would cancel. The right-hand side, I'd get a minus 4x. And I have to divide both sides by a minus 4. On the left-hand side, negatives cancel. 24 over 4 is 6. On the right-hand side, the negative 4's cancel. I'm left with an x. Should check. To check, I'd need to go 6 minus 2 over 4 times 6 equals 2 over 12. The 2 over 12, I don't need my calculator to know that that's 1/6. So when I do this on my left-hand side, I better get 1/6 because that's what that equals to. And if you want to use your calculator to reduce that, you could. So 6 minus 2 over 4 times 6. Beautiful. So I get a true statement that 1/6 equals to 1/6, so I know my answer is correct. I believe this will be the last problem. And it certainly is. So cross multiply again. Up and down, doesn't matter which side you put each on. I put the more complex side on the left side normally. So I get 3 times 2x minus 3 and 5 times x for my cross multiplying. The 3 times 2x minus 3 gives me a 6x minus 9. If you did this, if you minus 6x from both sides, that's completely fine, but you're not done when you do that. If you do that, you get minus 9 equals to minus 1x. You need to know what positive x is, so you'd have to divide both sides by negative 1. And when you do that, you'd get 9 equal to x for my answer. Again, because these are checkable, I should check. For checking, I want to plug a 9 in for my x's. I'm going to go 5 over 2 times 9 minus 3 equals 3 over 9. Right-hand side, I can tell that reduces to 1/3. I'm not going to use my calculator to do the right-hand side. But the left-hand side, I'll pull my calculator out because I'm way worn out. So the left-hand side, I get, beautiful, 1/3. So that's every even problem in this section. As you're going through the odd problems, there's answers for all of the odd problems in my answer section. You certainly should check your answers. If you see a problem and the answer has an extraneous component to it or a solution does not check, those won't come up on the test. There might be one on the review just because I know they come up in college algebra, but those would be the least concern of mine. Any problem in this section that has an extraneous solution, it's just not that important. So if you skipped over those, it's not going to penalize you at all. Tomorrow we're going to get into word problems. These are kind word problems. The word problems in intermediate algebra are so much easier than the word problems in beginning algebra. I really dislike teaching the word problems in beginning algebra and rarely teach the course because of the word problems. The word problems in intermediate algebra, you don't even have to be good at word problems at all to do really well with these problems. And when we get to the test, most everybody will get every word problem right. It won't be the thing that keeps you from getting an A if you don't get an A on the test. Oh, right, that's got to be way more than enough for this section.